Today, let us try to explore some basic concepts of chemistry, which we have got interest in finding the valency and to identify whether the given substance is an acid or a base. And the students will always have some anxiety about the valency and how the chemical reactions are there, whether we have to boycott the equations or something like that. But it's not generally required. Let us try to explore more in detail. So we know the elements are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. And also let us try to go up to 20 elements. So it is sodium, then we will be having magnesium, aluminum, silicon, phosphorus, sulfur. So we can see the atomic number of hydrogen is 1, for helium it is 2, for lithium 3, for beryllium 4, for boron it is 5, for carbon it is 6, and nitrogen is 7, oxygen the atomic number is 8, fluorine is atomic number is 9, neon is a inert gas and its atomic number is 10, and if we can go for sodium it is 11, magnesium 12, aluminum 13, silicon 14, phosphorus 15, sulfur 16, then we can go to chlorine, it is 17, argon 18, and so on. So if you want you can go for potassium 19 and calcium 20. So I would advise all the students to just at least know the first 20 elements of our modern periodic table. This periodic table of Mendeleev has been arranged with increasing the atomic number. So earlier the periodic table have been arranged with the increase in the atomic mass, but later they modified the Mendeleev table as a modern Mendeleev table where the elements have been arranged with the increasing atomic number. So I will repeat once again: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, followed by chlorine, argon, potassium and calcium. So these elements the students should know by their own. So we have written these things and let us try to see what is going to be atomic number. Okay. So now we are told these elements, these 20 elements have been arranged as per the increasing atomic number. So we can see what is the atomic number. So atomic number of hydrogen is 1. So hydrogen is an element which is also an atom. So this atom have subatomic particles, namely protons, then electrons, then neutrons. So hydrogen is an element, it is also called as an atom. This hydrogen atom is made up of subatomic particles, namely protons, electrons and neutrons. So these elements are called as subatomic particles. Okay, so these are three important components of an atom. So in case of this atom, let us take an hydrogen atom, it has two components. One is the nucleus. The central portion is called as the nucleus, surrounded by the electron cloud. So this is called as what? Electron cloud. Not only the hydrogen atom, any atom is made up of nucleus and followed by the electron cloud. In the nucleus, we have neutrons and protons. In the nucleus, we have the neutrons and protons, and in the outer orbitals or orbits, we have the electrons. We have the electrons. So it is called as E. Generally, we usually have the small letters for all these elements. So generally, we have electron as E, proton as small p, and neutron as small n. What are the terminology you can follow? Either you can follow the capital letters or small letters. It is not an issue. Now the idea is that an atom has protons, electrons and neutrons. Out of these three components, these protons and neutrons are arranged inside the nucleus, whereas the electrons have been arranged in the orbits or orbitals as electron clouds. So this is the general arrangement. Okay, here coming to the atom, an atom is either positive charge or negative charge or neutral. The answer is it's neutral. So the atom is neutral, which means it doesn't have any positive charge or negative charge. It is totally neutral. Whereas electrons are negatively charged elements, subatomic particles. Protons are positive charge and neutrons are neutral in nature. So we see in an atom itself, the electrons are negatively charged, the protons are positive charge, and neutrons are neutral. That is, they don't carry any charge. As well as I told you that atom is neutral in nature, which means how many electrons are there, how much, that the same number of protons should also be there. Then only the atom becomes neutral. Because we are not worried about neutron, because it doesn't carry any charges. On the other hand, if the number of electrons is 5, the number of protons should also be 5. Then only the atom will be what? Neutral in nature. If the number of protons is 7, then what should be the number of electrons? Yeah, it should be 7 only. Then only the atom become neutral. Now we have told the hydrogen, its atomic number is 1, which means the number of electron is 1. The number of electron is 1. So what is atomic number? Atomic number is nothing but number of electrons. Number of electrons. And for hydrogen it is 1. So the number of electrons is what? 1. Whenever I say the number of electrons is 1, what is the number of protons? It should also be equal to what? 1. Why? Then only it will be neutral in nature. Then only the atom will be neutral in nature. So we can see for a hydrogen atom, the number of electrons is equal to 1. Whereas the number of protons is also what? Number of protons is also should be equal to 1. Why? Then only it become neutral. Then only it become neutral. What about the number of neutrons in case of hydrogen atom? It is 0. There is no neutron in an hydrogen atom. There is no neutron in an hydrogen atom. So we see that considering a hydrogen atom, it has 1 electron, which is equal to what? The atomic number. Generally designated by symbol, the atomic number is given by symbol capital Z. This is indicated by symbol called capital Z. When I told the atomic number is the number of electrons, you may also argue with me. Why can't it be number of protons? Because both are same. So we can tell it is either the number of electrons or the number of protons. Because both will be same. If I have 5 electrons, there will be 5 protons. If I have 9 protons, I have 9 electrons. So whenever I say the number of electrons, it also means that it is not equal to what? The number of protons. So the atomic number can be defined, modifiedly defined as the number of electrons, or it's not and, it is or the number of protons. Okay, so we know what is meant by atomic number. So whenever I say the atomic number of hydrogen is 1, your mind should here tell it has 1 electron and 1 proton. For example, when I am going to tell the atomic number of let us say it is sodium is 11, what does your mind should strike? The sodium has 11 electrons and 11 protons. That your mind should strike. That is the basic of your atomic number. Okay. Now I will go to the, here in case of this hydrogen atom, there is no neutrons. There is no neutrons. Whereas in case of other elements, we will have neutrons also. But the hydrogen is a peculiar element where the number of neutrons is 0. Let us define here itself what is meant by mass number. Let us define here itself what is meant by mass number. The mass number is generally designated by capital A. So as I told you earlier, the neutrons and protons are located inside the nucleus, whereas the electrons are in the outer orbits or orbitals, and generally they are called as electron cloud. Whenever we are saying electron cloud, it means it is almost vapor form and it doesn't have any that much of mass. That much of mass with electron. They are just like clouds. They will keep on moving. They will keep on moving. So the mass of the electrons is generally negligible compared to the mass of the nucleus. I will repeat the statement. The mass of the electrons are generally neglected or can be negligible, is small compared to the mass of the nucleus. Compared to the mass of the nucleus. Which means the mass number is given by the things which are arranged within the nucleus. So it's nothing but what? Number of protons plus number of neutrons. Number of neutrons. Why I am telling this is the mass number? Because the mass of an atom is given by the mass of the nucleus rather than the electrons. So the mass number is defined as the number of protons plus the number of neutrons. Generally, I can tell you a general thumb rule. The mass of the protons is almost more than 1000 times as that of the number of electrons. Let me tell like this. 1 electron mass is 1 gram. Then the mass of the proton will be what? Approximately equal to 1000 gram. I want to just give a number so that you can feel that the mass of the proton is quite high compared to the mass of the electron. So compared to 1000, 1 gram can be neglected. What is the proportion between the mass of the neutrons and protons? Is that almost they are same. Almost they are same. The neutron will be slightly higher than the mass of the proton. Okay, if it is 1000 means the mass of the neutron will be say 1000. I will tell for example. I may not be right, but for you to physically understand the meaning, it will be 1013 gram. It will be slightly higher than the mass of the proton, but generally we can also take the mass is almost equal to the mass of the protons. That's what I am about to communicate to here. So we can see now the mass of the nucleus is 2000 gram, which is equal to what? 2 kilogram. Whereas the mass of the electrons is only what? 1 gram. So the mass is not contributed by electrons, whereas the mass is contributed only by the nucleus, and hence the mass number is given by the number of protons and number of neutrons. Okay. In case of hydrogen atom, there is no neutrons. So the mass number is nothing but number of protons alone. This is a peculiar case for hydrogen alone because there is no number of, the number of neutrons is 0 in case of our hydrogen atom. So generally if I have an element, let us say the element is capital X, let us say the element, it can be any element, hydrogen, helium, lithium, beryllium, whatever the element you know, we can generally call the element as X. For example, it need not to be X also. We are keeping as what? X. So X here indicates any element. Okay. And here the mass will be at the top. So the mass number will be at the top. So we will be giving the mass number as what? Here, and the atomic number at the bottom. So this is the way of representing an element. I will repeat. Let us say X is any element and A is its mass number because it is having more mass. So it should be at the top and the atomic number will be at the bottom. It should be at the subscript, whereas the mass number should be the superscript. Let us take one more element so that you will understand the importance of neutrons also. Let us take the case of carbon atom. Carbon, what is the atomic number? Hydrogen, helium, lithium, beryllium, boron, carbon. So the atomic number of carbon is 6. So what is your mind is now telling? The number of electrons is what? Number of electrons is? Yeah, you are right. 6. What is the number of protons? Any idea? What it should be? Yeah, you are right. It is 6 only. Why this should also be 6? Then only they will balance each other. Then only the charges will get neutral. 6 electrons means 6 negative charge. 6 protons means 6 positive charge. So when I am going to add these two things, the charge will become chargeless. It will become neutral. The carbon atom is also neutral because an atom is generally neutral in nature. It's not ionic form. It's not of ionic form. Let us say the number of neutrons in case of carbon is also 6. In case of carbon is also 6. So I can put it like this. The nucleus will have the neutrons and protons. So in the nucleus In the neutron will be 6, proton it will be 6. And coming to the electrons, in the first orbit, it can hold only 2 electrons, 1 and 1. Okay, it can hold only 2 electrons. In the next orbit, it can hold 4 more electrons. The idea is very simple. The electrons are revolving around the nucleus at certain orbits or orbitals. Now the first orbit holds 2 electrons. The second orbit holds 4 electrons. So we can see 6 negative charged particles have been balanced by 6 positive charged protons, and the neutron is already neutral in nature. So how to indicate this carbon atom in the form we have mentioned? So the element is C. The atomic number should be written at the bottom and the mass number should be written at the top. The mass number is A, the atomic number is Z, and the corresponding element is here is carbon, so C. So now let us come to C. What is the atomic number? Is 6, because the number of protons or number of atoms is 6. What is mass number? The mass number is the number of neutrons and protons which are contributing to the mass of the particular element. So here the mass number is 6 plus 6, which is nothing but 12. Which is nothing but what? 12. So this is the way how I have to represent the carbon atom. 6C12. I hope it's clear. Let us take another example. Let us take oxygen. When I am going to tell oxygen, its atomic number is 88 and its mass number is 16. So they will give like this. They will ask the question, what are the number of neutrons? Here this indicates the number of electrons. 8 is the number of electrons. So the same number of protons should also be there. So from this data, what you can understand? The number of electrons is equal to what? 8. How do we get it? By the atomic number. Because atomic number is the number of electrons. We also know that the number of electrons should be equal to the number of protons. So the number of protons is equal to what? That is also equal to 8. What is mass number? Mass number is given by the mass of neutrons and the protons. So the mass number is given as 16. We want to know the number of neutrons. What is the number of protons? 8. So the number of neutrons is also equal to what? 8. So we can see in case of oxygen atom, they will give the other way. They will give like this. Then they will ask what is the number of neutrons, or they will ask what is the number of protons. So you should have to tell 8 and 8, and the number of neutrons also arrived as what? 8, because 16 minus 8 will become 8. So this is the way how we have to write an element. In the next session, let us try to find the valency of each and every atom or an element. I hope it is clear. I have taken more time because I want to go from the basic, and so after in the future classes we will go a little speed so that we can pick up the concepts very easily. Thank you.